Welcome to part 8 of my bonding series. Today, we will look at how to draw dot and cross diagrams of molecules. We'll do lots and lots of examples from quite simple to a lot more advanced towards A-level and IB. We will also do 5 exercise questions at the end to test your knowledge. And during this entire video, I'm only going to use 5 atoms, which are hydrogen, carbon, nitrogen, oxygen, chlorine. And please have a look at bonding part 7, my bonding part 7 videos for more details of exactly how I drew their electron configurations, the outer shell electron configurations even. Okay, before we start drawing molecules, let's have a quick recap on the outer shell electron configurations. And I'm going to, this time, have the unpaired electrons in green and the paired electrons, usually in what we call lone pairs, in blue. So hydrogen, it has 1 unpaired electron. There we are. Now we've got carbon. Carbon is in group 4, so it's got 4 unpaired electrons. Here we go. In each quadrant of the circle. Now nitrogen, it's got 5 electrons. Now it's got 3 unpaired electrons and 1 lone pair of electrons. The top, I'm going to use the word lone pair a lot, by the way, today. Oxygen now, it's got 6 in its outer shell, so it's got 2 unpaired electrons and 2 lone pairs of electrons. Finally, we got chlorine in group 7, and chlorine has 3 lone pairs and 1 unpaired electron. Really important you know these 5 electron configurations. And remember, for bonding, only the green unpaired electrons can form bonds. The lone pair of electrons can never form bonds. Okay, so we're going to start by drawing diatomic molecules. In other words, molecules containing 2 atoms. Quite simple to begin with. And we'll start with number 1, hydrogen. Now, whenever you draw molecules, you always have overlapping atoms like a Venn diagram. And here, each hydrogen is sharing one electron, and the electrons on the left are with circles, and the electrons on the right are represented by crosses, hence dot and cross diagrams. Now we'll look at chlorine. Like hydrogen, they share 1 electron each. Okay, so you do, again, 2 overlapping circles, and the electrons on the right are going to be crosses. Remember to include the 3 lone pairs of electrons on each chlorine atom. Like so. Example number 3, we've got oxygen. Slightly more difficult because oxygen has 2 unpaired electrons. So what happens is oxygen shares these 2 unpaired electrons like so, and it's got 2 lone pairs on each atom too. And the 2 shared electrons are known as a double bond, as you can see there. The final diatomic molecule is nitrogen, and nitrogen has 3 unpaired electrons. So what happens is you form 3 bonds, so a triple bond. Remember to include both lone pairs on each nitrogen. Oops, it should have been a cross. Okay, we are now going to look at molecules with more than 1 atom. Now, molecules with more than 1 atom always have a central atom and an outer atom. The central atom needs to provide the outer atoms with the electrons they need. How do we know what the central atom is? Well, it is the atom closest to oxygen in the periodic table. Okay, so we'll start with water, H2O, and water has oxygen as the central atom and hydrogen as the outer atoms. And why is oxygen the central atom? It's closer to carbon in the periodic table, as we can see here in the periodic table. Now I'm highlighting it here, it's right next to it. It's closer to it than hydrogen. Really important to identify the central and outer atoms first. Once you've done that, you can then take care of the outer atoms. So hydrogen bonds. So make sure that's in place. Make sure the outer atoms are taken care of. So the oxygen provides each hydrogen with an electron. And you're left finally, as you can see in the diagram of oxygen above, with 2 lone pairs of electrons here. Cool. The next example we're going to be doing is, let me just quickly draw the line, NH3, otherwise known as ammonia. So nitrogen here is a central atom because it's right next to carbon. So we're going to draw a nitrogen atom surrounded by 3 hydrogens, like so. And the nitrogen provides each hydrogen with an electron, and it leaves behind a lone pair. Always remember to include the lone pair at the end on the central atom. Okay, let's draw a line here, like so. Yep. Example 3 is CO2, carbon dioxide. Now, carbon's a central atom, and each oxygen needs 2 electrons. So what happens is the carbon provides it with the 2 electrons represented by dots. So there we go. Each has a double bond now, and don't forget to include the 2 lone pairs on each oxygen atom at the end, like so. The final example we're going to do is of C2H2, otherwise known as ethene. Now, some molecules involve more than 1 central atom. And what we do with those is, to make it clear, is we treat each central atom individually and then combine them at the end. So let's just quickly adjust the pen size to size 5, just to make it clearer. Good. Yep, do green. So each carbon is bonded to 1 hydrogen, okay? And we must firstly make sure that the outer atom is taken care of. So it forms a bond with a hydrogen. And what does that leave us with? It leaves us with 3 unpaired electrons on each carbon. So remember what we said at the beginning. When covalent bonds are formed, the unpaired electrons combine. So these the 3 unpaired electrons on each carbon combine. So they pair up to form a triple bond. And I'm going to draw that now. Here we are, carbon 1, carbon 2, each bonded to a hydrogen, and the 3 unpaired electrons form a triple bond together. Cool. That's pretty much the hardest example in GCSE. Now let's do some exercises. Exercises even. So draw dot and cross diagrams for the following 5 molecules. One, HCl. 2, CH4, otherwise known as methane. 3, we've got HCN, hydrogen cyanide. 4, C2H4, otherwise known as ethene. And finally, N2H4, otherwise known as hydrazine. Pause the video and check your answers when you're ready. Okay, answer time. HCl, single bond, diatomic atom. The hydrogen and chlorine form a single bond, and don't forget the lone pairs on the chlorine. CH4 now, it just simply forms 3 single bonds with a hydrogen, fairly straightforward, represented like this. HCN now, hydrogen cyanide. Now, carbon is the central atom, and it forms a single bond with a hydrogen, and the nitrogen is there. So let's draw the single bond, and the nitrogen, it needs 3 electrons from the carbon, which it provides. And do not forget at the end to include the lone pair on the nitrogen, like so. Cool. Now we've got 2 central atoms, so C2H5, ethene. Now each hydrogen forms a bond. It leaves 2 behind, leaves 2 unpaired electrons on each carbon. So what happens is these 2 unpaired electrons combine like so to make a double bond. Finally, last but not least, number 5, we've got hydrazine. Now let's take each of the nitrogens individually. So each nitrogen has a bond with 2 hydrogens. Okay, like so. And what does that leave us with? It leaves us with a lone pair and a single electron on each. So it doesn't form a triple bond. It can only form a single bond, because remember, lone pairs cannot bond. So let's draw the molecule out to finish with. So you've got 2 hydrogens on each. You've got a bonded pair of electrons, and you've got a lone pair of electrons on each nitrogen. They often ask that to catch up. Okay, that is all for me for today. Thank you very much for watching, and don't forget to like and subscribe for more amazing content. Bye for now.